Okay, chapter 4, quiz corrections, which Asbury told me to make, so here it is. So number 1, table shows how many hours of video games kid plays per day. Write an equation, find total hours of video that can be played by William any number of given days. Okay, so key here, if we write an equation, it says find the total hours. So this is what we're solving for, which means our equation should start with that. And hours played is being represented by the letter H. So H equals something, and that helps out because that eliminates two answers right off the bat. And then since we put equations into this form of y equals mx plus b, the next thing we need is the rate of change. So if we look here, we look what is the hours changing by? That's plus 1.5, and the number of days is changing by plus 1. So our slope is 1.5 over 1, which is just 1.5. Okay. Since hours played is y, that leaves days to be x. So instead of x, we can call that the number of days. And then our y-intercept would be a different color here. How many hours would he play after 0 days? And using common sense, or this pattern here, we would see that if he had 0 days to play games, he would only be able to play 0 hours because no time had gone by. So this would be plus 0. Maybe we can even write it just to say we did. But plus 0 doesn't change anything. So our equation is just this right here, which happens to be answer B. Okay, nice and easy. All of my kids probably got that right. I don't know about Asbury's kids. That says use the equation for the information in the table and determine how many hours of video games Will would play in 16 days. So we have this equation, and we're just going to use that equation. So 1.5 times d, where d is equal to 16. So all you have to do is put 1.5 times 16 in your calculator, and you get 24. Just answer C. Another question my kids should have got right. Number 3. What are the domain and range of the relation? This grammatically is correct to say what are the domain and range, but it sounds terrible when you read it out loud. So normally, you just say determine. Determine the domain and range of the relation. Then it doesn't sound like bad English. Okay, fun fact of the day. Okay, so domain is a list of all of your unique x values. So we just go through the list and we put all of our x values. So we have, and our answer isn't going to look like it, but I'm going to do this correctly because I'm better than Asbury. And I know the domain should be listed in order from least to greatest. This is going to start with -5, as that's my smallest x. My next smallest is 2, and then 4, and then 5. So there's my domain, all my unique x values. And then range is the same idea, except that's a list of all of our y values. So let's pick a different color. So we have -5, -6, -3, and 7. So again, we list those in order from least to greatest. So our smallest one would be -6, and then -5, then -3, and then +7. So there's our domain and range, and if this was a well-written question, your answer would look exactly like that. Fortunately, it's not. So we gotta figure out which one's right. They just did it from left to right, so our domain should look like 4, -5, 2, 5. So let's see, 4. No, I'm missing one here. -5, -6. There's no -6 there. 4, -5, 2, 5. Okay, that's good. 4, -5, 2, 5. That's good too. So then we go to the range. So let's say -5, -6, -3, 7. That looks good. And then this one, oh, it's missing the 7. So that's wrong. That just leaves answer C. Put them in order from least to greatest, though. It won't kill you. Okay, number 4, express a relation as a graph. This is just a fancy 8th grade way of saying plot the points. which you did since 6th grade. So I know all my kids got this around, but you probably missed it because you forget that it goes x comma y, right? So our first point, 4, -3, which means 4 to the right and 3 down. Okay, there it is in letter A. So 4 over 3, well, that's not there. 4 over, no, it's not here either. And, oh, well, that was easy. This point is only in answer A, so A is probably correct. Let's check the other ones just to be sure though. -6, 3, so back 6, up 3, there it is. 1, 4, so to the right 1, up 4, there it is. And -1, 5, so left 1, up 5, there we go. Just plotting points. Alright, number 5, which relation is a function? So if it's a function, uh-oh, okay, sorry. If it's a function, x does not repeat. That's what a function means. So what we're looking for is a table where x doesn't repeat. Notice we don't care about y. I'm not going to look at any of these y values, which is good because now that I actually look at them, they're all the same in all 4. So I'm just looking for where x doesn't repeat. So A says 3, 5, 6, 9. Again, that looks pretty good, right? So I'm going to say maybe. Let's check the others. 3, 5, 3, 9. Oh, this repeats. That doesn't work. C, 3, 5, 6, 5. Oh, 5 repeats. And D, 6, 5, 6, 9. 6 repeats. So none of these are good except for A. That's it. Anytime it says function, you look for x to not repeat. Number 6. This was interesting because it's a multiple choice test that we gave you, and there's no answers here. So hopefully someone gave you some appropriate answer choices here. But we're just going to say yes or no, is it a function? And if it's a function, then x does not repeat. I'm going to write this every time I see the word function so I don't forget later on. So if we have a mapping, which is what this is, it's called a mapping, where they put the domain on one side and the range on the other. Okay? And each of these arrows represents one point. So this first point, 5 pointing to -6, is the point 5, -6. And our next one, we have -2 pointing to +2, so it's -2, 2. And we have -7 pointing to -6, and 3 going to 7. Okay, so that's all of our points, and then we see, does x repeat? So 5, -2, -7, 3. No repeating there, so this is a function. Okay. So now, what would make this not a function? So I think some people, they look at a mapping and they look at these numbers and they see, oh, well, these numbers don't repeat, it must be a function. But it's not about these numbers, it's about the arrows. Okay. So let's say, hypothetically, there was an additional arrow pointing like this. So that would give us another point that says 5, 7, right? And then this would stop being a function because then you'd have 5 and then 5 again. So if you want to know if a mapping is a function, you look at all the numbers over here and they can only have one arrow from each value. So if you ever have more than one arrow starting at something on the left, not a function. If that's confusing to you, if you just list the points, you can just look at the points. Looking at the points is pretty easy to determine if x repeats or not. Speaking of that, number 7 gives you a list of points to look at. So we check, does x ever repeat? So we have 5, 4, -7, 0, 2, 3, -3. So it doesn't look like anything repeats. The closest thing to something repeating is 3 and -3. It's the same digit, but they're opposites, so they're different numbers. So x isn't repeating. You can have a positive and a negative number. That's no big deal. So this is also a function. Okay. Almost there. Number 8. This is the only question that was remotely difficult. So if my kids missed one question, it's probably this one, and then they just got a 90. And that's okay, because they're good kids. Unlike Asbury's kids. So we have two plumbing companies, Allied and Ajax. How nice of them to both start with the same letter, so we can't name them. That's okay. So one charges $45 per call plus 30 per hour. So let's write that equation. So the cost of this first company, underline these in blue, we'll just color code it. So their cost would be equal to, so again, it's y mx plus b. So the next number we need is the rate, and rate should always be followed by per something. And then that doesn't actually help us because it says per service and then per hour. So what do we do now? Okay, that's okay. We keep reading. So it says how many hours. So that's our other variable. So x, excuse me, x is being represented some number of hours. So the rate we want is how much per hour. Okay. So it says $30 per hour, which means our rate has to be 30. Okay. Now if they change it and they said how many service calls would they need to make or something, I don't know how they'd have to write it. Usually time gets to be x. So 30h plus whatever's left over, and that's where we can use this 45 here. Okay, and that's equation 1. And let's do the other equation before we do anything else. So our second company says $60 per call plus 25 per hour. So it's still going to be cost, still hours here, but instead of 30 per hour, these guys only charge 25 per hour. But for them to go out, there's an additional $60 for them to show up. Okay. So we have two different equations, and we want to know how long would the call have to be for their cost to be exactly the same. Okay. So this place is going to cost more for them to show up, but it's less per hour. These guys, it's more per hour, but it's less for them to show up, and we're looking for where do they overlap. So what we're going to do is we're going to make a pair of tables here. Okay, we're going to compare hours to cost. And then if we need to know how many hours to pick, well, this is multiple choice, and it says 3, 4, or 5, or never. I can't check never, but I can check 3, 4, and 5. Right? Then if I put this into the calculator, so this would be 30 times 3 plus 45. So that's 90 plus 45 is 135. Next one would be 30 times 4 plus 45. Which is 165, and then I know my pattern is it's plus 30 every hour, so this next one would be 195. Okay, and let me move this a little bit over so I have room to put this other one. So our second company, same idea, still hours to cost, still looking at these hours 3, 4, and 5, but now our equation would be 25 times 3 plus 60. So this would be 75 plus 60 is 135. And then our next one, 25 times 4 plus 60. So 100 plus 60 is 160. And then this one's just going up by 25 every hour, so the next one would be 185. So where are they exactly the same? Well, at some point, they both cost $135. And that is at time 3 hours. Okay. You also could have used a little bit of common sense here. If we look at the difference in service calls, 60 minus 45 is a difference of $15. So it costs $15 more to get company 2 to show up, right? But then the difference in rates, 30 minus 25. It's $5 per hour, right? So it's a $5 per hour difference. So then the question is, how long would it take if you're going $5 per hour to get to $15. And 5 times 3 is 15. So we also could have got 3 hours, thinking of it as difference in intercepts compared to difference in rates. Okay? But I would make the tables because that's a little bit more straightforward. The last two, these are just graphing. These graphs aren't that great because they don't have grids, so we're going to use some knowledge about how slope and intercept works. So if we say, well, let's start with the intercept. So if our intercept is +1, that means our intercept has to be right here. And then we can eliminate any answer where the line is not on that point. So it cannot be C, cannot be B. So we have this line and this line. The second thing we look at is slope. If slope is negative, it has to be going downhill, right? So the only one with a y-intercept of +1 and a downwards facing slope is answer D. Okay, and you could have made like a table, right? X, Y, and then -2, -1, 0, 1, 2, and then so -2 plus 1, that's 3, and then that's what am I doing? This is, I forgot where I'm at. Oh, -1, that's 1. 1 plus 1 is 2. And then that's 1, 0, -1. And the only graph with these points is this one here. But I like the common sense way better because that's less writing, I think. Okay. Also, thing to point out, and we're going to use in the next one, is this is a slope of 1. All these slopes have a slope of 1. Some are positive, right? Top two are positive, top two are negative. But if the slope is 1, right, it means that for every 1 you go up, you go over 1. Okay? So if the slope is greater than 1, it's going to be steeper than this line. Like a slope of 5 would look like this, right? Let me draw a nice blue line here. So if the slope is greater than 1, it makes a steep line. Okay? If it's less than 1, if it's a fraction, like say 1/5, let's do Longhorn orange. 1/5 would look like up 1 over 5. Well, that's not quite Longhorn, but whatever. So whole number slopes are steep, whereas fractional slopes are less steep. Okay, and it's all compares to a slope of 1, like the ones written in this problem. And we use that to help us with this next question, where slope is -2x plus 4. Because again, there's no real grid line, so sort of have to like guess or use art skills to figure out where the points are. And I don't want to do that because I don't have skills like that. So if we start with our y-intercept +4, so our y-intercept is this point right here. So again, we can eliminate 2 of our answers. It's not on this line. It's not on this line. Our slope is negative, which means it has to be going downhill, but that doesn't eliminate anything, right? So what we look at, as we just said, this isn't a fraction, this is a whole number, so it's going to be steeper. So comparing these two, so I only have 2 answers left, say which of these lines is steeper, and that's this one right here. So I know this is my answer without having to really consider any of the points except the y-intercepts. And if you don't believe me, we can check this, because we have this point right here, that's actually on the axis, that's the point 2, 0. And if we put that into our equation of y equals -2x plus 4, so does 0, which is our y, equal -2 times 2 plus 4. So this is -4 plus 4, which does indeed equal 0. So this statement is true, which means this point is on that line, which means this has to be the correct answer. But we could skip all this if we recognize how slope actually works and what it looks like when we graph it. Okay? So now hopefully all of your grades are as good as my grades. Alright.